So welcome back. Just to reintroduce myself, so I'm Cathy Cobey from our Canadian EY office. And my title is our Global Trusted AI Advisory Leader, which I find my title in it itself as actually a great conversation starter, because most people, when they hear it, invariably ask me the question, so can we trust AI? And my question is always very guarded, because even with all the knowledge I have, all the examples that I've seen, there is very little AI out there that is fully trustworthy. And really, there probably always will be an element of mistrust around AI, and there should be. It's a different type of technology than we're used to, and hopefully by the end of this session, I'll give you a little bit of sense of that, particularly considering that the group here is very knowledgeable about RPA. And so I'll try and, as much as I can, kind of give an example of how, or different examples about how RPA is different from AI and how we're starting to see that manifest into different risks. So in looking at AI, particularly as a technology, it is actually a really broad spectrum of technologies. Going from chatbots, which have a machine learning component to it, to autonomous vehicles, more software-based AI applications like you might see in banks or in healthcare implementations. And so that's probably one of the issues as well, is that where RPA is a fairly narrow technology in regards to how it operates, although it has a broad spectrum of use cases, AI is actually broad in regards to the technologies that you can employ, as well as then the use cases. And so that's where you're trying to get some of the complexity. And what we have found in all the studies that have been done is that there's actually a very high desire for organizations to start utilizing the benefits of AI, but actually very low adoption at this point. Even within RPA, where you see a lot of it in a lot of the back office functions, the operation functions, we saw finance being a big user of it, HR. Even within those more traditional lower risk functions within corporations, you're still not seeing a very high prevalence of AI. So when you look at the technology cycle of AI, it's still in its very infancy. Even though you might have heard that AI has been around since the 1950s. It was coined then as a term, and it's evolved and had a couple of winters, which have now been, everyone hears, solved through the vast amount of data that's available, as well as the computing processing that's now available. But still, as a enterprise tool, AI is still in a proof of concept stage. And particularly in those more higher impactful areas that we'll hopefully get into. And one of the reasons why you're seeing a low trust still in AI is because they do have a high failure rate still. Now, part of that is because with AI, we need to start to redefine what failure means. So AI, by its design, it's designed to use incomplete information. It's designed to make predictions about what the next step is, the next value, whether that is this cancer, is in an autonomous vehicle, what is the right direction that I should go? Should I stop or go? Is this image a car or is it a dog? All of those are different decisions, but they all have one thing in common, is that that decision was made based on a prediction. And that prediction comes with a probability. And the probability is never 100%. If you were getting 100% probability, it'd be much cheaper to use RPA or another technology that is rule-based. The reason you use AI is because you can't build the rule set, or there is ambiguity, or there's missing information, and so you use predictions. AI is actually going to also go through an evolution. Right now, those predictions are, for the most part, stopping at a human. It's providing insights to a human operator to then decide how I want to move forward. But we are going to start to see AI predictions being attached to also prescription, and that's where AI then starts to actually make decisions. So in an autonomous vehicle, you already are seeing that combination of prediction with prescription. But in healthcare, where you're using AI to look at an X-ray and diagnose whether something is cancer, you're not having the AI then meet with the patient and give that diagnosis to the patient. It's still going to go possibly through an X-ray technician, and for sure it's going to go through a doctor. So that's where you need to also be thinking about what is the ultimate use that you're going to be using of your AI. And the reason why there's such a high failure rate for AI is because of the environment of which AI operates. If you have a human trying to make predictions, you're going to expect that sometimes it's going to fail. If you have a human making decisions and you have trained it and it's training, the human's prior knowledge, the experience that they have in certain use cases is fairly defined, and then you ask it to make a prediction maybe for a whole other use case, they're going to have more difficulty. Their prediction rate is going to be lower initially. And so we have to be careful about how we think about failure and actually build AI with the expectation that there will be areas of which its confidence in its decisions are lower than you want, and therefore you need to have good exception processing, but also too that you actually have some quality control, because sometimes the AI thinks it has a high confidence in its decision, but it's wrong. And so how do you actually identify those failures? And right now, one of the reasons why, even though we know that there's a lot of studies that show that AI can be actually much higher in coming up with accurate predictions than human operators, most people in surveys will still choose to go with the human operator because they don't trust the system. They don't trust the AI, and particularly because they don't understand it. They can't decide or know when it's going to fail. And because they can't know when it's going to fail, they aren't going to trust when it is right. And so that's a big thing that we're going to have to do with AI, because I see all the predictions of how AI is really going to take off. It's going to be used in all these areas, but so far I'm not seeing that pace of change because of this mistrust. And so we really need to be thinking about how we can address the mistrust in the technology. Now, I mentioned before about how AI has so many different parts to it. What I see in most of my clients is that AI comes into organizations through two different paths. We heard a lot today about the role of robotics and how you hit parts in your process of which you need some decision to be made, you need some cognitive intelligence to contextualize and understand information. So we're certainly seeing a lot of combinations of RPA with AI. And not only software robotics, but also hardware robotics. So I was just reading on the weekend about how they're designing physical robots to be used in disaster recovery and disaster situations. And what they're finding, though, is that actually it's really hard, as it was mentioned earlier, to teach physical robots all the human dexterity that we have. And so they're actually, again, doing a combination of using virtual reality, having human operators that can help to kind of help the robotics. So the robot will be operating in an environment, maybe helping in a fire, and as they're navigating, they might lose their balance. Well, robots right now have difficulty actually correcting themselves, and so that's where a human can actually very quickly feel that the robot is falling and actually bring it back. And so that's where we're seeing even human augmentation with robots, where we're actually helping the robots versus what's usually thought, which is the other way around. The second area that I see a lot of AI progression on the journey is through analytics. So if you have an organization where you've been using a lot of analytics, mainly that's been with structured data. We're seeing a lot of the data scientists now start to use machine learning because then they can develop those models faster. They might get higher predictions through those models. But particularly if you're a more regulated industry, what we're finding is that the AI machine learning is still using fairly, on the spectrum of AI, more simplistic techniques for machine learning. There has been some move into the deep neural networks, but because of the explainability issues around deep neural networks, they're being used in more of those areas that aren't regulated, that you don't need to have high explainability. The other thing I thought I'd mention is that AI does not sit by itself. This is usually, it sits within a broader system. There can be a lot of Internet of Things and sensors that are used to now collect more data. Certainly the whole data engine that feeds it. There could be where there are different process steps where it goes from AI to robotics and back again. Definitely there's some use of analytics in addition with AI and your legacy systems. And so you really need to be thinking about how AI is interacting with all of those different technologies. Now the 4 items that I have up here on the screen definitely are not new in regards to technology. As we've been building technology over the last century, we've been having to be thinking about these. But be honest, we've actually relied on a lot of human developers to be embedding this into the code of which we design and the rules that it is based on. And so as we start to design artificial intelligence, we'll start to learn, we'll start to create its own rule set without the overseeing of a direct developer. That's why this is starting to come up again in regards to, okay, as AI learns, how can we actually adjust those learning mechanisms? How can we provide oversight over those learning mechanisms and the framework, the decision framework that it creates to ensure that all of these are met? And so, certainly from an ethics perspective, what's also coming up to the fore is that these hidden societal issues that we've all kind of known that existed but just kind of put to the side are really coming up to the fore. Because as we think about trying to now have a system, an AI system, be trusted now to make decisions that we've historically made, are we comfortable that it's making those decisions with the same value system that we hold? And the problem is that, one, we don't all hold the same value system. I think we've got multiple countries here, so you each have some different values based on the country of your origin. Whether you're associated to a religion, your family. And the other difficulty is that we lie. Surveys have certainly showed that when we're asked what we would do in an ethical dilemma, what we say we would do is usually different than what we actually do within this situation, because we usually think we'll be more idealistic, altruistic than we really are in practice. Social responsibility, because of the broad use cases that AI is intended to have, has actually brought an issue, and certainly workforce management and the impact that all robotics and automation will have, including AI, on the workforce, but particularly with AI, because, be honest, it affects a whole different group of people. We have had many different transformations, of which lower level, more routine jobs have been automated, over the last century, but we're now talking about even replicating our knowledge base. And as much as we had some concerns, but not as big of concerns to have technology that could go faster than us, process faster than us, we really, when we start to think about AI that can think better than us, make decisions better than us, maybe even explore and understand emotions better than us, then it really starts to hit what we think is the real differentiator of us as our humanity. And I think that's what is a bigger issue here with AI. Accountability is also a really big issue because of the way that AI operates and how it's designed. It's very much a collaborative type of technology. A lot of open source, a lot of different components coming together from very different players. There is no one UiPath or Automation Anywhere or Blue Prism that can just come in and build out a whole AI system. It really does usually require a multitude of components. And if you think of the autonomous vehicle crash that happened last spring, where the woman was killed, and as soon as I heard about the accident, I started waiting for, and I very quickly happened, where all the different organizations that had components in that car started to put their hands up and say, it wasn't my sensor, it wasn't my AI, it saw the woman, but this was the problem, and someone else's must have been the problem. Everyone else put up their hand to say it wasn't me. And the reality is it might not have been one component. It might have been the integration of the components. It might have been just it didn't really quite have the functionality that it needed because it was dark and the conditions. Maybe the cameras were a bit dirty. There's so many different things that can go wrong. And who's going to be accountable for that? We have a system of law that is very much based on liability. And so how do we actually then start interpreting that in this new context? And then the reliability. I've given some examples already. I'll give you a couple more later in regards to how, what would I call it? How the conditions of which AI operates can sometimes be so narrow that it falls anywhere outside of that band. It can impact its, the way that it generates its decisions. And so you really need to make sure you really understand the way it was trained and how that training will impact what you can or cannot expect it to do. So a couple of the reasons where AI is different from RPA, one of which it's the same, is it is very much a business-centric led technology. It's not IT-centric in any way, even more so than RPA. I mentioned before about how its decisions are probabilistic, and this is where it is most different from RPA. It is not rules-based, and that's the reason why you're using AI. If you could rule-base it, you could build that functionality in a much cheaper technology, because AI is expensive to run. It may seem cheap to build, but it has a really high maintenance tail. It requires a lot of retuning, a lot of oversight. Some of the control mechanisms don't currently exist right now for some of the technologies, and so you really need to make sure that you're looking at the full life cycle of AI. I find a lot of AI projects right now aren't even given a return on investment or benefit realization requirement, because those are just even so hard to define at this point. But it's important to be thinking about what your outcomes are. AI is designed to dynamically learn. It can be put into production, of which it is not allowed to continually learn, but then you don't really generate a lot of the benefits in having it to be able to continually learn as it processes more and wider variability of production data. But you do have to think about, how do I manage a technology that is constantly being recoded every time it processes a transaction? And so it does create some issues there. And then as well, AI is only as good as it was trained. And I like to think of AI less as a technology and more using thoughts about how would a human risk manifest itself in this particular transaction. So if you think about that house that Craig put up earlier, if you took someone who'd only been trained to do a very routine task and then elevated it up to the 7th floor, how would you expect its performance to be? You'd expect its performance to fall, to not be as good, maybe even be terrible. And yet we don't always think about that same analogy when we're taking AI into broader use cases than it was trained for. And then as well, AI processing is fast, very fast. And we have an AI application that we designed earlier this year with one of our provincial governments to help them process payments. And they went from 47 days to process these payments to 9 minutes. So if you can imagine, and the only reason it was taking 9 minutes was because of some latency time with their legacy systems. But if you can imagine, we created other problems, because all of a sudden we created a cash flow problem, because they were actually counting on having that cash in their pockets for 60 days, and now we could pay out. But what it did is it provided some opportunities for them to go look for some better terms for their payments. So what we had done last September was actually identified what are some of the elements that need to be in place in order to trust AI. And we basically created, first of all, this development wheel around AI, basically 8 major steps. You've got identifying your problem, collecting your data, preparing the data. The big area that is different in developing AI is here in modeling and training and validation. Because this piece doesn't happen linearly, it doesn't happen in a week. It happens over and over and over and over again for a span of sometimes months. And so when you think about when they actually need to go put this AI into production, and quality assurance comes in and says, okay, can you show me your testing approach? Can you show me how you modeled this system? They're like, well, I need to take you through months of iterative decisions, some of which we moved backwards into, some which we leaped forward. We went back in and brought something that worked better and combined it too. It's a very iterative process. And so the normal processing you have in organizations in order to manage these technologies can be very different with AI. A couple of the attributes that, again, are not any different than a human making a decision, but we have more trust in that humans can actually make these decisions with common sense, with their value and social system. And so as we go to develop AI, we need to incorporate all that into the AI's decision making, but also we also are feeling, let's do better this time. If we know that human decisions in the past have been biased, how can we build AI that isn't biased? How can we have more concrete explanations as to how decisions are made versus right now where we rely on the judgment and the poor memory recall of humans? How can we build AI so that it is, safe from adversarial attack? And I'll go through a couple of examples of that in the next slide. How can there be transparency in regards to when it is being used, how it's being used, and what the impact it will be to the users? And particularly with GDPR, there is an expectation that if someone is materially impacted by a decision of AI, that you are transparent that it's being used, and you give them the option to opt out. And so it'd be interesting to see right now how many people actually, given full knowledge, will actually trust the AI versus opting out and using a human decision maker. And then performance is a really big issue because AI has primarily been in academia. So it doesn't have all the control mechanisms of current technologies. And with so much innovation in AI through deep neural networks, reinforcement learning, those are so new, less than a decade old, that they don't actually have a lot of the testing mechanisms, the logging mechanisms. And so how do you actually prove performance? And once it's in production, it hasn't shifted away from its originally intent. So here's a couple of examples, and I'm hoping at the end of this I don't get classified as the fearmonger, because I do feel it's important for everyone to be aware of this, but my ultimate goal is to make everyone aware and then think about, okay, how do we solve for this? Because right now there's so much focus on the functionality of AI, we forget that we need to similarly invest into the control functions of AI. So a couple of examples of just how, subject to adversarial attack it can be. The first one is an interesting one, and this is now almost 2 years old, so there's been a lot of solutions to this that have come up, but there was a research group that found that they could reverse engineer what were kind of the main decision points in a picture that an AI was using, and by just changing one or two of them, it could actually have it see something completely different, going from like a teddy bear to a gun, from an airplane to a house, like very significant changes. And the reason is that AI doesn't look at the full picture and context, it only looks at certain pixels. So if you can affect those certain pixels, of which I wouldn't even be able to recognize that change with my human eye, you can actually completely change what AI sees, which is a problem. And you've also, heard of where you can put decals on a stop sign and it can change what it sees and not even see the stop sign. Like, those are very real challenges that we need to be thinking about. This bottom one is interesting. There were two algorithms that were designed to detect whether an image was a horse. And they both in the lab had really high rates, like 94%, I think, accuracy rates. But when they actually went into production, one's performance fell somewhat, as you would expect. The other one just tanked. And the reason is that they found out that when they reverse engineered the decision framework, that one of them actually was making a decision based on a copyright tag that was at the bottom of all the pictures they were sent. And so what the designers hadn't realized is that by tagging the pictures for their own use, they also provided that tag to the AI. It was efficient. It realized, I don't need to look at the picture, I just need to go down to the copyright tag. But as soon as it started to ingest pictures that didn't have that copyright tag, it could no longer use its decision framework. I think a lot of you have probably heard of the algorithm used in the judicial system within the US to try to identify whether current inmates would actually perform their crime. And what they found is no matter what they did, they could not stop the AI from creating and determining ethnic the ethnicity of the different individual. And we've seen this also with Amazon's HR recruiting app, which they also indicated that no matter how many of the direct fields that they told it not to look at, it was still able to detect some of these fields. It could be through the postal code because there's a more prominent ethnicity in that postal code. With the resumes, it was even that they found that women actually wrote their resumes using certain language that was different from men, and even based on that, it could actually, and with a high probability, calculate the gender of the recipient. So it can be quite insidious in regards to how it can recreate variables of sensitive and personal privacy information that we'd want it not to use in certain decisions. The other thing is there are certain decisions that some of that information is valuable, and where bias is actually very important to the decision framework. And so it isn't so simple to actually eliminate bias, because some bias is actually really integral to certain decisions. The last one here is basically a chatbot which had to be pulled after 24 hours because it was put into the public domain, and so many teenagers and kids thought it would try to break it that they actually were able to, within 24 hours, have it swearing, be very bigoted, be very discriminatory. Like, it just did not follow any of our social norms. And it's because the developers just hadn't thought that they needed to put in some kind of ethical basis to its operation. And so these are just a couple of examples that really need to be thought through with every AI application, to be thinking about what are the particular areas of risk that need to be addressed. So one of the things that we've done is try to think about, okay, how can you actually quantify risk? Because there certainly are a lot of AI applications that don't have a lot of risk, those that would fall into the green domain. And thinking about, okay, how can we actually identify those AI applications that are in the green domain versus those that are in the red and need some type of remediation plan. And so we actually have currently right now developed a model that looks at 3 different areas. The first is technical risk, thinking about what is the goals and objectives of which you've asked the AI to do, how have you designed it in regards to the functional capabilities it's asked to do, and to Craig's earlier point, the more functional capabilities it has to do, and this is like, does it have to hear, does it have to see, does it have to understand context of words, does it have to understand its physical environment? What is the learning and incentive approach that you're giving it? What are the environmental conditions? Is it having to operate like as a drone here in this room where it's fairly stable, or is it out into the general populace? And what is the level of human autonomy? But just understanding all of that wasn't enough, because the use case of which you use the AI is very important. And so what we found is that, if you took an AI that was designed to detect an image, it could be used to just put images into an album. Or it could be used by an autonomous vehicle to identify if there's a person standing in front of it. Very different use cases. And the risk profile are very different. And so we basically have the impact assessment questionnaire that helps to amplify that risk depending on the use case. And then we have control effectiveness here on the horizontal, which is how effective are the controls that you've designed. And you have to recognize, for many AI applications, the functionality doesn't even exist to get you to a truly effective control environment. There's always going to be areas that currently functionality doesn't exist. And so it could be quite expensive to actually employ more human-based controls versus automated over the systems, and it could really slow down the processing. So that's where we actually really encourage our clients to use this model at the design stage, so that you really go in understanding where those issues are and can really think about at the design stage, do I have to then make some different decisions on maybe some of these technical components to kind of match the risk to my risk tolerance as well as to the prevalence of the control environment. So here are a couple of the more governance areas that you want to think about when you're starting to involve AI. Do you have an AI advisory board to be thinking about some of these more social elements of AI and the ethical considerations? And are you kind of bringing in a broad spectrum of people who can really act as effective challengers, such as from philosophy or law? Have you built design standards to deal with some of the differences of AI and ensuring your designers have that front of mind? Are you really understanding where all your AI is. With such a business-centric, decentralized way of developing AI, we're finding a lot of your businesses are just hiring direct data scientists who are starting to build out this AI without a lot of governance. Do you have an impact assessment where you can evaluate them each against each other? Do you have the validation tools that are needed and the continuous monitoring tools that are required once it's actually put into production? What about the awareness of your data scientist, of your enterprise controls? I find that a lot of data scientists coming from academia just aren't used to working within an enterprise-wide structure and make mistakes in regards to sharing too much data out onto the open source because they're used to a much more collaborative mechanism. And then, do you have an independent audit group that can come in that have the data scientists to be able to work on this? So I've got here in the slides, which you can read through, just a couple of the examples of the different risks of AI and some of the controls that are needed. Where it's maybe suboptimal. It works really well in the lab, but doesn't do so well once it gets in production. You can have biased outcomes. Unwarranted reliance, I think, is I've talked about a bit in regards to expecting it to be able to function when it hasn't really been trained that well. Lack of explainability, data privacy breaches, especially when it can now start to share information out. Having inadequate supervision, because it has been proven that we humans are actually not really good for supervising AI, as much as that is one of the most common controls right now for AI. And the reason is because we trust technology too much. Also, because AI processes so fast, we lose focus. And we're much better in supervising big events and doing investigations than kind of watching it real time. So we're going to need more automated monitoring functions and then cyber risk. Just leave you with this quote, which is, that the idea that AI can be delivered as a finished product without further human investment is a recipe for failure, and this is why it has such a high maintenance cost. Because while older rules-based systems could be set up, configured, and then ignored for a few years, AI needs to be retrained whenever new data is available, which is essentially constant. So you need to be recognizing that you're going to need a really high maintenance cost. Doesn't mean that AI does not have real value. It certainly does, and we've seen that with a number of clients, but they invariably always underestimate the maintenance costs available. So just as you go to think about building AI, a couple things to ask yourself, is AI becoming a new form of shadow IT? Have you been incorporating trust by design and accountability into your AI program from the start? Do you have the methods to evaluate and measure the technical risk and the impact of AI? Is AI embedded in your governance and control practices? And lastly, do you have the technology, the talent, and the strategy to really optimize your AI investments and its performance? Because right now there is a significant war for talent, and data scientists are very heavily specialized, and so you got to make sure that you've got everything matching together. I know that was a really quick introduction to AI. I hope that I've given you some thoughts to be thinking about in regards to how you can think about your AI program. There certainly is a lot of opportunities for AI. I'm actually an optimist of AI. I think it's already here. It's going to be here more and more over the coming years. But it also has the risk of creating some pretty major failures. And so you really need to be going in with your eyes wide open and really ensuring that you're guarding against some of those failures. So thank you so much, and enjoy the rest of the conference.
Thank you, Cathy. What a fascinating topic, trusted AI. Something that I think we'll hear more and more about as we develop more AI use cases. And I've just spent a week out in Palo Alto with our own AI labs, and there's some fantastic use cases that are being developed. So I'm the only obstacle now that stands between you and lunch, and we are running a little bit behind time. So I'll quickly introduce you to the mix of topics that will be addressed after the break. So all the pillars that Aurelia talked about, we'll deep dive into them. There's three main topics. The first is, how can I manage my processes and data to maximize automation potential? The second is, how do I manage the changing workforce landscape? And the third, how do I redesign my technological environment to be flexible and to be scalable? And following the lunch break, please follow the instructions to the location. As I mentioned, we are running a little bit late, so if we can follow the instructions to your selected workshop topics. Workshop A will be held in this room, and the other 2 workshops will be held close by, so please do ask any of the staff that are outside. So after the 2 hours of the focus sessions, we'll be waiting for your return here in the plenary, and we have some really exciting demonstrations of innovation. Come and see some of the future authentication methods using your very own typing patterns and deep dive into your own online consumer behavior, generating machine learning models used in customer analytics. I guarantee you there will be some aha moments when you hear some of these presentations. But for now, please do go and enjoy lunch, and don't forget to visit the demo booths on your way out. Thank you very much.